You are watching video on SEE Grade 10 subject Science. The chapters for Grade 10 will be discussed in this video series. So the content of this video will give you complete explanation of the chapter Energy, chapter 3 Physics part. The chapter is going to be explained in part 1, 2, 3 and 4. Now this is third part of the explanation. The chapter broadly consists of 4 parts: classification of sources of energy, major sources of energy, alternative sources of energy, and energy crisis. So we have discussed classification of sources of energy and major sources of energy in previous parts. Now we are going to study alternative sources of energy. Alternative sources of energy definition: the renewable sources of energy that are used as the alternative of non-renewable sources of energy are called alternative sources of energy. Mainly non-renewable sources of energy are fossil fuels, the energy sources which are used in place of fossil fuels. These are called alternative sources of energy. All perpetual sources of energy fall in this category. Perpetual sources of energy means everlasting sources of energy. Examples: solar energy, hydroelectricity, biomass energy or biofuel, gobar gas, nuclear energy, wind energy, tidal energy and geothermal energy. These are the examples of alternative sources of energy. Solar energy and hydroelectricity have been discussed in previous part. Solar energy and hydroelectricity have been discussed as major sources of energy in Nepal. So these are discussed. In Nepal, we use solar energy, hydroelectricity, biomass energy, to some extent wind energy in a small amount, and this many sources of energy are used in our country. Okay, tidal energy is not possible in our country. Geothermal energy and nuclear energy have not been harnessed in our country. Biofuel, definitions of alternative sources of energy and their examples as well. Biofuel, the source of energy which is obtained from plants and animals is called biofuel. The source of energy which is made from organic origin, materials of organic origin, is called biofuel. For example, biomass and biogas. Biomass are wood, firewood, dung, animal dung, cow dung, buffalo dung, agricultural waste and weeds. So these come under biomass. Biogas is gobar gas, which is made from animal dung and agricultural or organic waste by fermentation process. Fermentation process means a kind of decaying in presence of bacteria. So gobar gas is made up of methane mainly, carbon dioxide and hydrogen. Now wind energy, the energy obtained from strongly moving air or wind is called wind energy. Strongly moving air. Okay, so energy obtained from strongly moving air is called wind energy. So this is possible in mountainous regions in our country. Tidal energy, the energy obtained from tides of seas and oceans is called tidal energy. The tides occur on seas and the oceans due to gravitational force between earth, sun and the moon. Okay, the sea level, ocean level rises. So the rising of sea level and ocean level, the water is collected, and this collected water at dams and the reservoir made to fall, and when water falls with a greater speed, then hydroelectricity can be obtained in the same way as we do in hydroelectric power station. Okay, the mechanism is same as in hydropower station. Okay, the raised water level is collected in dams and the reservoirs made at the height. So thermal energy, geothermal energy, geo means earth, thermal means heat. The heat present deep inside the earth, that is geothermal energy. The energy obtained from the heat present inside the earth is called geothermal energy. Two sources of geothermal energy are volcanic area and spring water. From these two places, geothermal energy can be obtained in more amount. These are the sources of geothermal energy. Geo means earth, thermal means heat. So heat present deep inside the earth. Nuclear energy, when a heavier nucleus splits or light nuclei combine together, there is a tremendous release of energy in the form of heat and light. It is called nuclear energy. So we are talking about atomic level in this case. When a heavier nucleus of an atom splits or light nuclei combine together. Light nuclei of two or more than two combine together, there is a tremendous release of energy in the form of heat and light. It is called nuclear energy. So nucleus of an atom, nucleus of an atom. Okay, so reaction occurs at the level of nucleus, and at that time tremendous amount of energy will be released, and this is called nuclear energy. Two types of nuclear reactions, nuclear fission and nuclear fusion, produce nuclear energy. There are mainly two types of nuclear reactions called nuclear fission. Fission means breaking up, and fusion, fusion means combining. So fission and fusion reactions produce nuclear energy. Now, nuclear fission and nuclear fusion, what are these? We are going to see definitions and examples. Nuclear fission, when a heavier nucleus splits into lighter nuclei with the release of large amount of energy, it is called nuclear fission. We are talking about atomic level, nucleus of an atom. Heavier nucleus like that of uranium, uranium 92 235, 92 is atomic number, 235 is atomic mass. So heavy nucleus splits, breaks up into lighter nuclei. At this time large amount of energy is produced, which is called nuclear energy, and this is fission reaction, breaking up. Nuclear fusion, when two or more light nuclei combine to form a heavy nucleus under certain conditions with the release of a large amount of energy, it is called nuclear fusion. On the other hand, when two or more lighter nuclei combine together, we are talking about the nucleus of an atom, combine together, light nuclei combine together to form a heavy nucleus under certain conditions, special conditions, with the release of large amount of energy, it is called fusion reaction. For example, hydrogen atoms combine together to form helium atom, and at this time a large amount of energy is produced, which is called nuclear energy. So this is an example. This reaction occurs in the sun. Okay, due to nuclear fusion, tremendous amount of heat and light produced in the sun. So hydrogen atoms, 2 1 H1 2 1 H1, 4 atoms of hydrogen in total, combine together to form one atom of helium with the liberation of this particle, positron particle, and large amount of energy. So this is the example of nuclear fusion. Okay, so this is word equation I have written here for easier understanding, and this is also word equation, whereas this is chemical equation, this is chemical equation. So conditions required for fusion reactions, special conditions are needed. These are extremely high temperature and extremely high pressure that is present in the sun. These conditions are available in the sun. Okay, so these are the nuclear fusion and nuclear fission reactions, and we can see the differences between nuclear fission and nuclear fusion reactions. Sometimes it is asked in the exams. Okay, two differences between nuclear fission and nuclear fusion. Nuclear fission reaction, in this nuclear reaction a heavy nucleus splits into lighter nuclei with the release of large amount of energy, whereas nuclear fusion, in this nuclear reaction light nuclei combine to form heavy nucleus with the release of large amount of energy. So in case of fusion reaction, extreme temperature and pressure are required, whereas nuclear fusion, extreme temperature and pressure are not required. Nuclear fission can be done under ordinary conditions of temperature and pressure. Now we are going to see this point in nuclear energy. Nuclear energy is considered as alternative source of energy because there is large deposit of radioactive substances to produce it. Only few countries are using it. So the question is asked, nuclear energy is considered as alternative source of energy, give reason. Nuclear energy is non-renewable source of energy, okay, because once the radioactive element is used to produce nuclear energy, it gets finished. Okay, so this way it is non-renewable source of energy, although it is considered as alternative source of energy because there is huge deposit of radioactive substances which have not been used so far. Only few countries of the world are using it. That is why large amount of energy can be produced, can be obtained from these radioactive substances. That is why it is considered as alternative source of energy. Now the next point is mass energy equation. Mass energy equation. So you see the amount of nuclear energy produced in the nuclear reaction can be calculated by using this equation, which is called mass energy equation, given by Einstein. Einstein mass energy equation, E equal to mc square. This is called mass energy equation, and this is for the calculation of energy produced in nuclear reaction. So in this equation, E stands for energy produced, small m stands for mass lost at the time of reaction. Negligible mass will get lost in producing products. Okay, so there is mass lost in the reaction which is in very small amount. And c is square. C stands for velocity of light, which is 3 into 10 to the power 8 meter per second, and this is the square value of velocity of light. E equal to mc square. C is velocity of light, m is mass lost. Okay, so in nuclear fission reaction, uranium for example 92U 235, nucleus is splits to form barium and krypton nuclei. In this reaction, there is negligible amount of masses lost, around 0.2155 atomic mass unit, which is very small amount of mass. Now this negligible mass loss produces enormous amount of energy because it is multiplied by the square value of velocity of light. So tremendous amount of energy is produced because this negligible amount of mass will get multiplied by velocity of light in square value. Okay, so this is mass energy equation, and we are going to see more questions here relating to the same topic here. Large amount of energy is produced during the fission of uranium atom. Give reason. Since E equal to mc square, mass energy equation, mass lost in fission reaction is converted into energy. C, velocity of light equal to 3 into 10 to the power 8 meter per second, is proportionality constant in the equation. In this equation, C is the proportionality constant with a high value. This makes the value of energy produced or the released in the reaction extremely high. So this is the question that you have seen in the board exam. Now Nepal government encourages the use of biogas or the biofuel. Give reasons. Or biomass or biofuel is the most suitable source of alternative energy for a country like Nepal. Give reasons. Biogas is obtained from biogas plant where animal dung and organic waste are fermented due to bacteria. Nepal government encourages installing of biogas plant or use of biofuel due to the following reasons. Now our government encourages use of biofuel or the biogas plant. The reason behind this is Nepal being an agricultural country, around 80% of the population is engaged in agricultural activities. The raw materials needed for biogas plant is available free of cost and in large amount. Biomass is renewable source of energy, so it never gets exhausted. Energy obtained from biogas plant is pollution free. It minimizes pollution to a large extent. And installing of biogas plant is not very expensive, so government provides subsidies to the farmers for biogas plant installation. So these are the reasons government encourages establishment of biogas plant in our country. So the next question relating to this topic is government is giving high priority to solar energy. Why? Solar energy is renewable source of energy which is used as alternative source of energy because deposits of mineral oil are limited and mineral oil will get exhausted by 2037 AD. This estimation given by research data shows that there will be a severe energy crisis in near future. So in order to conserve fossil fuels, or mineral oil, use of solar energy is encouraged. Besides this, solar energy does not cause pollution in the environment. It is a perpetual source of energy. So this is a pollution free source of energy. Now the next question relating to this topic is, in the context of Nepal, wind energy can be taken as a profitable probable alternative source of energy. Give two reasons. Wind energy can be taken as probable alternative source of energy in Nepal because Nepal is a mountainous country with high potential of wind energy. Annual average energy potential is about 3.387 megawatt hour per meter square. Potential area of wind power is 6074 square meters, and it is easier to construct and install wind turbines and also faster than establishing hydropower stations, hydropower plants. Okay, so these are the reasons wind energy can be probable alternative source of energy for a country like Nepal. With this, we finish discussion of part 3. Now we are going to do part 4 in the next video.